Alright, so now we've had a look at angle rules and triangle rules. We've had a look at Pythagoras' theorem, as well as in 2D and 3D. We've introduced these trigonometric functions and their respective graphs, and we have an okay understanding of the inverse function. Now, I proposed that we could use the idea of adjacent, opposite, and hypotenuse sides in a right-angled triangle, as well as sine, cos, and tan, to find either missing lengths or missing angles. Now, we can almost do this, we just need to know one thing. That's this idea of SOH CAH TOA. Now, we don't need to know SOH CAH TOA to do these calculations, but it makes it a little bit easier to remember. So, what do these mean? So, in each case, so let's take SOH. We have the first letter denoting the trig function, right? So, sine, cos, or tan. So since this is s, we have sine x, right? And then the second letter denotes the side on numerator, and the third letter denotes the side on denominator, right? So here we have the numerator being O. So we have O and that side being a denominator. But what do these O and H, what does this O and H mean? Well, it's going back to these sides, so it's either the opposite, adjacent, or the hypotenuse. So here, because we have O and H, we know that it's the opposite over the hypotenuse, like that. And that's our first rule here. So we can put this in red. Sine x equals the opposite over the hypotenuse. That's a shorthand way of writing opposite and hypotenuse. Now let's look at CAH. So CAH, well, C, the trigonometric function beginning with C, is cos. And again, our numerator will be the second letter, which is your A, or the adjacent. And then we have H, which if we remember from this, is the hypotenuse. Now, finally, TOA is tan x equals the numerator, which is O, or opposite, and the adjacent, which is just that. And now we have these three formulae. We can use these. And bear in mind, if the angle on the triangle says theta, this can be converted to sine theta, for example, and similarly for the others. So this is how you use SOH CAH TOA. And so long as, if you remember those, you remember these three formulae. And once we know these formulae, we can start figuring these out. So let's start with case 1. Let's start with case. Right? So case 1 is if we have a missing length. Okay. So let's get this triangle here. We know this angle is 38 degrees and 12 centimeters here. And we want to find this angle, this side y. So we have this missing length. Now what we need to figure out to find which one of these formulas we're using is we need to say which two sides are we interested in. Now, to me, we're interested in this side here. Why? Because that's the one we want to figure out. And we're also interested in this side here. the hypotenuse, because we already know what that is. This side here, the opposite, we don't know the value, and we don't want to know the value. So that's the side we don't care about. But these two, the hypotenuse, because it's opposite to the right angle, and the adjacent, because it's adjacent to this angle, are the ones we want. So let's use these formulae. So which formula incorporates the adjacent and the hypotenuse? Well, it's cos, right? So we have cos x equals the adjacent over the hypotenuse. So let's put in these values. So this x here is your angle. Again, it could be theta. It doesn't really matter what we use to denote it. But what we can do is we can replace that with the angle. So we have cos 38 equals the adjacent, which is y, over the hypotenuse, which is 12. And now, all we need to do is times both sides by 12 to find out what y is. So we get y equals 12 cos 38. And you can use your calculator to find the exact, the decimal value of that. There's also, if let's say these were swapped around, so let's just put this in a box. And if I said, consider this triangle. It's a similar triangle, and that's still 38. Sorry, that's a poor, or small writing, I guess. Right. So, what we can say is this is the opposite, and this is the hypotenuse. So now, we just need to figure out which one uses the opposite and the hypotenuse, and it's sine. So let's get our formula. Sine x equals opposite over hypotenuse. Okay, and then let's put in our values. So we get sine x, which is our angle, which is 38 degrees, equals 12, the opposite, over y. And now you can see it's not as nice as this one. It's not as nice as this, because we can't just times through by y. But what we can do is we can switch the denominator with this value. So we get y equals 12 over sine 38. And again, if you just put sine 38 into your calculator, you can work this out. If you want to know why this is true, it's because we can times through by y to get y sine 38 equals 12. And then we can divide by sine 38, giving us 12 over sine 38 degrees. But that is in case you just don't understand this step. Okay, so let's think about the second case. So case 2 is when you have a missing angle. So you have two sides which are the same, or which you know, and you want to find the missing angle. Oh, also, sorry, these will be in centimeters. So let's have this angle this time, or this triangle. This time, let's denote that as theta, and the angle is up here. And then we have these values, right? So now, what we can do is we can figure out theta using these formulae. So now what we can say is, okay, which sides are we interested in? We're interested in the adjacent. Remember, the height is now the adjacent because the angle is here, not here, and it's adjacent to this angle that we're interested in. And this is our opposite. If we go to our formulae, we can see that tan x is the only formula with the opposite and the adjacent. So what we do is we write that equation. So we have tan, well, theta in this case, tan, we can actually just use the normal form, adjacent over, oh, sorry, it's TOA, so it's opposite over adjacent. And now let's substitute our values. So our x becomes theta, and then we get 5 over 8. Okay, and now it might become apparent that that theta isn't by itself. We have tan theta. So, and it's actually something we haven't learnt thus far, of how you can get theta by itself. But what we can actually do is we can apply the inverse function of that trigonometric formula to the other side. So we can get theta by itself if we apply the inverse function to the other side of the formula. In fact, what we're doing here is we're just applying the inverse formula, the inverse function to both sides, like that. And because we've applied it to both sides, the equation doesn't change. But the inverse of tan and tan cancel out. Now, you don't need to know why they cancel out, but if we go back to the graphs, I can kind of give you a reason why. So remember how we were talking about how sine x is, or the x here is this axis, and then when you put in x, it goes up to the input, from the input to the output, and then it goes, and that's how you get the output. But remember, the inverse function is the opposite way around. So it'll go here and go back to the original value. So you'll get your x back if you applied both functions. So these cancel out like that. And you just get theta equals tan minus 1. Right. Again, you don't really need to know that. You just need to know that you can flip this around. So you can move the tan from one side to the other if you apply the inverse function. And on your calculator, if you press shift and then the tan, you'll be able to get that inverse function, and you'll be able to calculate the value. Okay.